G'day YouTube, Warbles on a lot here. I've been repairing Chinesium. The particular failed Chinesium here in that is the final drive shaft on the Easy Washer 2.0, to quote from the instruction manual. The machine has been, clearly, apparently, conceived and designed by a fairly clever individual or a team of such people, and then their design has been processed by some production engineers who decided that this final drive gear would be just fine operating in something like a 2-to-1 step-up ratio on the final driven gear down in the bottom of that there slot. And the wicked, evil, devious production engineers clearly decided that this drive gear would be just fine if it had the same size, I don't know, nylotron shaft as the one employed on the driven gear. Now, I would have thought that this shaft emerging from the planetary gearbox would probably be the most highly stressed drivetrain in the whole construction. But whereas the designer possibly would have required or suggested a steel shaft, the production engineers, clearly having been captured by the bean counters, and the demons from the marketing jism department, they have decreed, determined, decided, ordered that the product be crippled by putting a weak spot, a nasty little weak spot, in its most highly stressed component, so that the device would look really, really good in the innovations catalogue. It could be manufactured in its millions, distributed across the planet. It would look great and probably process perhaps 5 loads of clothing while on a camping holiday, after which it would fail in service. It would then be consigned to landfill, because who's going to be able to get spare parts for something that's been bought out of an innovations catalogue next time it's holidays and the thing's being brought into service again? One of my father's pet hypotheses, theories, sermons, stemming from the fact that his father was a woodsman and a wheelwright, and my old man got his commercial employment start in life jumping around the cinders in his father's blacksmith forge. And he said that a backwoods mechanic or a blacksmith, self-taught, actually has to be considerably cleverer, smarter, better at the job than the people who go to university and have doctorates, degrees, masters, qualifications. Because when their university educated design fails in service, it's the backwoods mechanic who has to pull it to pieces, figure out what's broken, figure out why it broke, then determine how to try and repair it with the materials to hand. So what we have here is a shaft that's twisted off. My personal decision was to repair it with a wood screw up the centre of the broken shaft, held in there with 24-hour industrial strength epoxy resin. And because it failed in load, the end surfaces across the fracture were twisted, malaligned. And after I got the whole thing assembled, I noticed that it wasn't going to turn out correctly aligned unless I could somehow use the end of the shaft that pokes out from the gearbox for alignment, and then quickly, while the glue was still setting, and happily I used 24-hour araldite, manufacture a clamp setup which would hold it in true. So what we have is Meranti pine that's been drilled with a brace and bit and then cut out with a hacksaw and bifurcated so that this could put pressure onto the outboard end of the clamp, correctly selected so the grain runs that away. This could suitably strengthen the wood and prevent it from breaking, while this one fixed the impromptu wooden clamp onto the device. Now, is there any way I can get that to show us whether... I don't think it's too bad. I don't think it's too bad at all. Oops, wrong hole. There we go. Oh, it's still got a wobble. But happily, the gears that's going to go on it are both Nylotron. Actually, I don't think that's too bad. Near enough for government work. There we see the fracture, and we also see the sticky tape that I applied to hold the glue in place. I will of course have to clean out that drive slot because there's some epoxy resin filling up the bottom end of it on both sides, as you can see. But I do have a sort of sneaking of the suspicion that with a wood screw held epoxied through the old fracture, this is going to be stronger than it was when it left the factory. And on the other hand, maybe not. That's pretty close to being where it originally was. Sadly, it's not a perfect job. But I've got to say, it's better than it was before I put that clamp on. I think it'll run. See if I can contrive to hold it edge on. I'd say it's probably between 1 and 3 degrees out of alignment. Okay, so I've cleaned those slots out on both sides. Let's put the thing back together and see what happens. Gearbox replaced. Final drive gear. Repositioned. Not perfect. But better than nothing.
CJ was one of the most delightful people I met. course of working on this book. It's a young man who suffers from autism, who is fascinated by maps. He just loves maps. He knows everything about maps.
Well, seems to be working.
Road atlases. He's got an almost photographic memory. So this young man, CJ, who just adores these things, he
Well,
volunteered at the library.
I can't notice any difference.
The library wants maps and atlases.
Yep, it's all working. So the next thing to worry about are those two hairline cracks in two of the expanding petals, which lock the handle into the gearbox. There should be 6 and there's only 5, and I think I've lost the little bit, but I'm going to have to attempt to get some glue into those hairline cracks before they get any worse, and if and when that fails, then I'll just glue the handle into the central hole and I'll lose the 5:1 step-up ratio spin dry, because to be honest, when you try and run the spin dryer on this outside socket, which gives you a 5:1 rather than 2.5:1 spin step-up ratio, the machine hops and bangs and jumps around so much that it's really not worth it. So there you go, and now you know, and here endeth this little episode of Adventures in Repairing Broken Chinesium. Wobbles on a lot to YouTube. Ciao.